Hi everyone, we're going to solve trig equations, give a general formula, and give 6 solutions. Basically, these are the harder ones from the previous video. This is where we have this 2 theta for our argument. So I want to solve for theta equals, sine of theta equals -1, and we get 3 pi over 2. So theta is 3 pi over 2 plus 2k pi. But we have 2 theta, so what we need to do is 2 theta equals 3 pi over 2 plus 2k pi. And now we divide, so theta we divide by 2, so you get 3 pi over 4 plus k pi. Alright, so basically, k is any integer. So when you're doing your 6 solutions, we're just going to let k equals 0. And when k is 0, we're going to get 3 pi over 4. When k equals 1, we're going to get 3 pi over 4 plus 4 pi over 4, which gives me 7 pi over 4. And when k equals 2, we get 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4. And k equals 3. Do you see what's happening here? We get 3 pi over 4 plus 12 pi over 4, which gives us 15 pi over 4. And if you notice, you can keep going on, but you can notice there's a pattern here, especially after you do 3 or 4 of these. You get 3 pi over 4, 7 pi over 4, 11 pi over 4, 15 pi over 4, and you should know what comes next, because we're going by 4s here. We're adding 4 pi's. See, from here. So the next one would be 19 pi over 4. And then the next one would be 23 pi over 4. And once you see the pattern, you can kind of do that. The next one is we have sine of theta over 2 is negative square root of 3. So first I'm going to solve for sine of theta, and we're going to get this equals 4 pi over 3 plus 2k pi, or this means k is any integer, or we have 5 pi over 3 plus 2k pi. But that's not what we have as theta. We have theta over 2, so basically I set this up. I'll just put the k there. I messed up. And then we also have this one. Now, multiplying both sides by 2, you're going to get theta equals 4 pi over 6, which 4 pi over 6 is 2 pi over 3. So we're going to get, this one's going to be theta equals, on the 4 pi over 3, you can get it 4 pi over 6 plus pi k, and this one's going to be 5 pi over 6 plus pi times k. Oh, 4 pi, sorry. Alright, so, and this is really just 2 pi over 3, this one. So, when you set this up, you're going to get, actually I divided here, sorry. Let me redo this real quick. Okay, sorry. So you're multiplying by 2. So we multiply by 2, you're going to get 10 pi. The first one's going to be 8 pi over 3 Sorry about that. And 4 pi, and the next one's going to be 10 pi over 3 plus 4 pi k, or 4k pi. I don't know, I get mixed that up. So there's two solutions, and then when you write them all out, you're going to get 8 pi over 3 and 10 pi over 3. That's when k is 0. Now when k is 1, so let me do a line here. When k is 1, you're going to 8 pi over 3 plus 4 pi, which is 12 pi over 3. And this would be 10 pi over 3 plus 12 pi over 3. And adding that up, you get 20 pi over 3 and 22 pi over 3. Do you know what the next two would be? Okay, well, let's do, when this was k equals 1 here. This was k equals 1. So let's do k equals 2. So we'd get 8 pi over 3 plus 8 pi and 10 pi over 3 plus 8 pi. So that's going to be 8 pi over 3 plus 24 pi over 3 and 10 pi over 3 plus 24 pi over 3. And that's going to equal 32 pi over 3 and 34 pi over 3. And those are your 6 solutions. I'm going to squeeze it down here. And that's your 6 solutions. Next one, we're going to first solve for tan of theta equals -1. There's 2 places, but since the period of tan is pi, we just need to pick one. So our theta would be 3 pi over 4 plus k pi. But our argument is theta over 2, so we're going to 3 pi over 4 plus k pi. Now multiply everything by 2, and we're going to get theta equals 3 pi over 4 plus 2k pi. It was 3 pi over 2, sorry. All right, so we know when k is 0, we're just going to have 3 pi over 2, and then we're going to check the others. So let's do 1. So when k is 1, we get 3 pi over 2 plus, this would be 4 pi over 2, and that's going to give you 7 pi over 2. And let's try k equals 2. So we have theta equals 3 pi over 2 plus 4 pi, which would be 8 pi over 2, which gives us 11 pi. And if you can see here, there's a pattern. It's going by 4s, because we're just going to, for k equals 3, for example, would have 3 pi over 2 plus 12 pi over 2. Because when you plug in 3, you get 6 pi. And then that's going to give you 15 pi over 2. So all we're doing is we're adding 4. So 4 plus 15 is 19 pi over 2. And I keep running out. The next one would be 23 pi over 2. I don't know why I don't leave enough room. Okay, the last one. Oh, that's it. Okay, the next set we're going to do is solving trig equations with arguments like, let's see, they're going to be like cosine of 2 theta minus pi over 2 equals -1. And we're going to do 4 of those. Thank you and have a nice day. Bye-bye.